So here's the lesson for Pre-Calculus 31.3. This is part 2. In part 1, we were given an equation for a transformation, and we applied the transformations to generate the new equation. In this part, what we're going to do is we're going to be given two graphs. Somebody grab that door, shut it, it's getting pretty loud. What we're going to do is we're given two graphs, the original and the transformed graph, and then we're going to generate the equation for it. Okay? So it's like the other way around. Instead of generating the graph given the equation, we are going to generate the equation given the new graph. Okay? All right. So here's an example in your textbook that we're going to take a look at. So the graph of y equals g of x here is the transformation. So in red, this right here, g of x, is the transformation. F of x is the original function. Okay? Now, if you just take a look at this, and maybe I'll just zoom in just a little bit here. If you take a closer look at this, you can see a couple things. All right? It appears, what's one thing that you see? I'll ask you. What's one thing that it appears has happened in the transformation from f of x to g of x? Sorry? Okay, it appears that it has moved up too. Okay, we'll check that out later. All right? But yeah, that's a good observation. Because you're probably looking at this part right here, right? And you're probably looking at this part over here, and you're saying, well, this is down at the x-axis, and this is up too. Okay? That's a good guess. Like I say, we're going to double check that later. What else do you notice has happened with this? A vertical stretch. Okay, so it appears that maybe this has jumped up a bit, right? It's been stretched up vertically. Okay. Anyone see anything else or any other possibilities? Sorry? What did you say? Okay, so it looks like it's been moved over to the left 7 units. Okay, that's a -7. Here's a 0. Okay, good guess. So what were you going to say? Were you going to say something else, Melanie? Okay, so it could be horizontally. Okay, it could be horizontally squished up or compressed. Yes. So remember, it's a little tricky sometimes when we're thinking it could be a vertical stretch or it could be a horizontal compression. Oftentimes with some graphs they look very similar. So this is great. That's totally good. Let's take a look. And we could, just given this information, honestly, there could be more than one answer, really. But yeah, those are good observations, and that's where we want to start. Now, when we're trying to determine the equation, so I'll zoom back out here. When we're going to determine the equation, go back to 100. What we're going to do is, you're going to want to probably look at those stretches first, okay? So you're going to want to compare. Now, yes, this graph has probably moved. Oh, the other thing we didn't say is there could have been some kind of reflection here. What kind of reflection could there have been? Tough to tell. Yeah, about the y-axis, or about the vertical axis, right? There could have been. This looks pretty symmetrical, so we don't know. There could have been a flip there. So there might be more than one option for this equation, right? All right, so first thing you want to look at is the width of this, okay? Let's take a look at the width, because somebody said it might be a compression, okay? Very possible that it is. It could be a stretch as well. But let's just measure. This is 8 units here, right? 8 units wide. See that? And what's this one? Okay? It's 2 units wide. Okay, so someone could say, well, that appears to be a horizontal compression, right? And because of the shape of this graph, that could be logical. If we're talking about a vertical stretch, now here's the one thing with the vertical stretch, okay? If this graph continued on forever, and it didn't stop here, if it continued on forever, then this would continue on forever, and this would continue on forever, and then it would be like, yeah, it looks like it could be a vertical stretch, but because we have some end points here, okay, the vertical stretch, we have to just consider that. Sorry, tripping over my words. So what's the height here? This is how many units? 4 units? Okay, that's 4 units. And what's the height here? 8. Okay, so from 2 to 10. Good. So if we're looking at a vertical stretch, we could be looking at a vertical stretch by a factor of 2. Or we could be looking at a horizontal compression, right, by a factor of 1/4. Okay? Now, maybe it could be written both ways. Does anyone see anything why we would want to lean one way or not accept one of the stretches? Not saying that there is, but I'm just saying, is anyone thinking anything that they want to share we can talk about? Okay, does everyone see that it could be a horizontal compression or a vertical stretch? Does everyone see that? Okay. All right. So yes, that's fine. Now, what about the movement here? So here's the thing. If this stretches, let's say this stretches and it goes up by a factor of 2, right? That means that, and I'm just going to erase some of this stuff. That means that each of these points, like this is a 1, so that's going to go to 2, right? That's where that's going to go. This is a 4, it's going to go to 8. So we're kind of roughly going to be looking like something like this, right? Right? Does that make sense, or does that not make sense? Because what did we have here? We had 4, and now this is 8. So that's a vertical stretch of 2. So does that make sense, or do we have to do something else? It's a combination of both. Does everyone see that? It's a combination of both. So it's not necessarily one or the other. It can be a combination of both. Because here we have the overall height, the overall distance here, but we don't have that overall width. So it's going to be both. Okay. So this, what did we say? 8 units, and this is 2, right? So if we bring each x value, what's that, divided by 4, that comes over here. This comes back to a 1. This comes back to a -1, and then we kind of look like this. So in red here, does this look like it's now the same shape as the transformed graph? Yeah. Okay? So it's a combination of both. It's not one or the other necessarily, but it's actually both. So let's write down these before we get too far into it. Okay? What does the vertical stretch by a factor of, what was that, 2? Which one is that? Vertical stretch by a factor of 2. Which parameter? Vertical stretch? A. Thank you. So A is A 2 or 1 over 2? 2. A is 2. Good. B, we've compressed by a factor of 1/2, right? It's half as wide. Or is it a quarter as wide? Which one was it? Quarter. This one's a quarter as wide. Right? So B then is 4. Is it 4 or 1 over 4? 4. Yeah. If B, remember, if B is greater than 1, then we've got a compression. So this matches up. Okay, awesome. Everyone with me so far? Is that making sense? Okay, so we're building our equation here. Building our equation. Now what's left? H and K. And we did mention that there looked to be a shift, a horizontal shift and a vertical shift. So now, again, if you do your stretches first, then you can just take a point on the original graph, or the one that we have dotted here, and the corresponding point on the transformed graph, and then you can just simply count. Right? So this does appear to be 7 units to the left and 2 units up. Okay? So what does, okay, so H is -7, right? Because we're actually moving 7 to the left. It's going to show up in here as a what? It's going to be X. It's going to be X plus 7. Very good. You have to keep that in mind. And then the H is going to be plus 2, right? So for the solution, we just put that all together now. And we have Y equals 2, that's our A value, and then we aren't actually given the actual expression of the function, so we will just kind of use the f of x there. So f of, and inside here we need to include our b value, which is 4, bracket, x. H is -7, so that's going to show up as, we said, plus 7. Okay, make sure you have all the right number of brackets there. And then it's going to go up 2, so plus 2. Okay, so now, did we do that right? Any questions about that, or did you have a question? All right, so the question goes back to the h equals 7 and the 8 and the x plus 7. Yes. So if I'm asking you for the actual h value, like just this value right here, if it moves to the left 7 units, h is -7. But what you're saying is, in this equation, isn't it plus 7? And yes, it is. So in the equation, if you see x plus 7, what that actually means, because look at this is x minus h, right? So x plus 7 is actually x minus negative 7. You see that? So the h value is actually negative 7. H is negative 7. But you're right, it shows up in the equation as x plus 7. Okay? So right, I mostly talk about x plus 7. If you see x plus 7, then it goes to the left 7 units, which is absolutely true. But if I ask you for just the h value, then the h value, this negative sign, does actually mean that it goes left. Sorry? Oh, what about y? Yeah? Okay, yeah. The 2 here? Yeah. Yeah. That's right. So if this k value, yeah, I didn't write down k, did I? Oh, I wrote h twice. Hey, thanks. Okay. No one noticed that? I think I said k, but I wrote h. Anybody notice that? Yeah? No? Okay. Yeah, that's k. So, the, yeah, what was I doing there? Okay, you're right. There is a bit of an inconsistency there. Sorry. So the actual k value, it is plus 2. That was correct. And it does show up as a plus 2 over here. But if I wrote it on this side of the equation, over here, then it would be y minus 2. So it's actually y minus k on this side of the equation. So this is the other way you could write it. But what they kind of told us was that, we should write it in this form here. So they kind of give us the outline. I know it's a little bit confusing, but if you study this format, then it's only the h that's kind of the opposite sign. So this, I'll get rid of all this gobbledygook here. This is our final answer, right here, and that creates. What did I erase? Oh, did I accidentally erase this? Sorry. Thank you. Yes, that's right. So that's our answer for that. Now, what I'm going to get you to do is I'm going to get you to do a question on your own and see if we can come up with the same answers here. All right. So why don't you take a minute here and take a look at this. You don't have to recopy it if you don't want to in your book because it's in your textbook. But I want you to try and tell me what the equation for this parabola is down here, g of x. Okay, we're looking for g of x. And consider the parameters, right? So a, right, times f of b of x minus h plus k. So in terms of the original f of x. So as you just kind of check here, this is sort of what I've got so far. Does anyone have the same parameters? Anyone have? You did? Did you have different? You had different parameters? Okay. So let's see. What is the actual equation once we put this all together then? It appears that I've got -3/4 times f of, I don't have a b value because I did a stretch. So what we'll do is we'll graph this just to see if we're missing anything. But I've got f and then x. My h is 3, so h, that's x minus 3, and then minus 4. Now if you want to check this f of x is actually x squared. So that would mean that g of x would actually be looking like this. The f of x part would be x squared, so it's x minus 3 squared minus 4. So why don't you graph both these, this one and this one, and see if we get a parabola that's the same. And I should mention here with this a value, what I did was I took a look at this. If you go over 2 units and you go up 4, right? If I went over 2 units here, I would only go 1, 2, appears to be 3 units. So it seems to be compressed vertically by a factor of 0.75 or 3/4. And it's flipped, so I made it negative. So let's just take a moment and graph both those. Can't really see the intercept here, but what we could do is we could calculate the intercept. But it looks like there is a point right here that this was given on the diagram. We'll just kind of erase some things here. And this point right here would be 1 and -7. So what you could do is you could go into your calculate setting here, calculate a value, and then you calculate x equals 1 and see what you get for both these graphs. So for this initial graph it's 1, 1, and if you use the down cursor there, we've got 1, -7. That checks out. What about the other one? It's 5, -7, right? So if we did calculate value and I plugged in x equals 5, hit enter, it'll show me, okay, 25 for this one. And if I go down here, 5, -7, that seems to add up. That lines up just right. Okay? So, by graphing, and again, the y equals, you plug things into here. Okay? Make sure you use your brackets properly. Also make sure that this is your negative here, and this is your minus sign. Okay? Don't mix those up because the calculator won't like you. So that's a negative, that's a minus, and that's a minus. But it appears that that's a valid equation. Now, did you guys do something different? Did you have a b value instead of an a value? Yes? Okay. You got a, so you got a is -3, a is -3, and b, like just 1/2, 1/2, and h and k is the same. Okay, did anybody else get this? Anybody else do this? Oh, is that right? Okay, you did. All right, so you did a, okay, negative. That makes sense. We'll flip it, and then you did 3. So you did 3 times. So you flipped it here, and so it's 2 and then -4. So you'd be a point there, and then then it was times 3. So you went all the way down here to 12. Make it really kind of skinny like that. Is that what you did? Okay, you thought of it that way, and then 1/2. Okay, so 4. That would make this 1, and so instead of 1, 1, it would be 1 and 3 right here. And then you squished, and then by 1/2, so you doubled the width. All right? Okay. Let's just see. I tell you what we'll do. Let's graph this, because we're pretty sure this one's right. So let's check that one. A lot of you did that one, so let's check it. So -3 times, this is x, and that was the same, right? -3 all squared. Oh, sorry, the b though. I gotta put your b in there. So 0.5 and then bracket x minus 3 bracket squared minus 4. So is that what you're saying? So you had a... Sorry? Oh, yeah, I see. You're right. So let's insert another bracket there. Okay, so that's sort of what you had there, the -3 there. Yeah? Anything else? No? Okay. Okay, so it's graphing it, and doesn't appear to be any different graph showing up there. It seems to be the same as mine. So I tell you what we'll do. Let's check a couple values. So calculate, and we'll put in, what did we say here? 1, -7. So let's put in 1, and we'll enter. So we got 1, 1. For my graph, we've got -7, and for your graph, we've got -7. Okay. So let's do another one. Let's do that x equals 5. Okay, 5, 25, -7, and -7. So yeah, so it appears that this is the same parabola. How many of you then had that other equation? Okay, so both of those seem to work. And you could, algebraically as well, you could plug values in for x and see if you get the same y value to see if both of these are correct. That's totally true. Like, for example, the 5, right? 5 minus 3 is 2, times a half is 1, squared is 1, times -3 is -3 minus 4 gives you -7. So you could plug your values in there and check. Okay, awesome. Good job. That's a couple different ways of doing the same question. Okay, so if we start off with 1, here's another way to see it. Okay, so there's x squared, and here's ax squared. So what I did was I changed this 1 to 0.75. Now why is that? Because over 1, 1 squared is 1. But if you multiply that by 0.75, you get this point on the black graph right here. Let me just zoom in there. Okay, so instead of over 1 up 1, over 1 up 3/4. Over 2 should go up to 4. Right there, 2, 4. But this is now on our diagram, it showed that it was only up 3 units. Okay? The other students in the class said, well, what if A was 3? So then over 1 went up, over 1 went up 3 units to there. And then they said, well, I have to spread this out so that this point comes over here, right? And so then what they did was they said, well, let's spread this out horizontally, stretch it by, double. So that means the B had to be 1/2. So then that brought that out to here. Okay? So if I show that, whoops, let me show this one. Okay, so let's say this was 3, right? And then they said the B value here instead of 1 is actually 0.5. Okay, and that is actually the same as if this one here, the black one, was 0.75. See, the exact same. So that's why, 0.75. That's what I did, and 3 and 0.5 here is what some of the others did, but it ends up to be the same one.